Hi there. Welcome to Physics at Fire. Today we are going to discuss about importance and limitations of Coulombs Law, principle of superposition, and continuous charge distribution. Let's start with the importance of Coulombs Law. It signifies the inverse square dependence of electric force. The vector form of Coulombs Law is important, as it helps us specify the direction of electric fields due to charges. Now, coming towards the limitations. Electric charges must be at rest. Electric charges must be point charges, that is, the extension of charges must be much smaller than the separation between the charges. The separation between the charges must be greater than the nuclear size, that is, 10 raised to power minus 15 meter, because for distance less than 10 raised to power minus 15 meter, the strong nuclear forces dominates over the electrostatic force. Now, let's start with principle of superposition. It will actually deal with the scenario where we will have a system of multiple charges, as compared to Coulomb's law, it have only two charges and we have to find force on one charge due to another charge. But, in this we have to find force on one charge due to all other charges present in the system. Now, what is principle of superposition? It states that total force on a given charge due to a number of charges is the vector sum of individual forces exerted on that charge by the other charges. And each individual force is unaffected by the presence of other charges. Let's suppose we have multiple charges in a system, like Q1, Q2, Q3, Q4, and so on, up to Qn, and let's denote their position vectors as R1, R2, R3, and so on, up to Rn. Now, let's have F1 for force on Q1 due to other charges and use superposition principle. So, F1 will be equal to F12 which is force on 1 due to 2, plus F13 which is force on 1 due to 3, and so on. Which implies, F1 is equal to KQ1 Q2 by R12 square by R12 cap, plus KQ1 Q3 by R13 square by R13 cap, plus KQ1 Q4 by R14 square by R14 cap, and so on, up to KQ1 Qn by R1n square by R1n cap. Similarly, we will have for F2 and so on. Now, if we generalize, we will have Fi is equal to summation of K, Qi, Qn, by R, I, n, square by R, I, n, cap, from n is equal to 1 to n number of charges, and I represents the force on the particular charge. So, let's start our ending topic, that is, continuous charge distribution. As we know that charges are discrete in nature, according to quantization of charge, but if we see from macroscopic level, then we are not able to see the discrete nature and charge appears continuous. We don't need to go deep inside this topic, we just need to remember what charge densities are, so it is actually charge per unit dimension. We have three charge densities. Linear charge density, denoted by lambda, which is charge per unit length. Superficial charge density, denoted by sigma, which is charge per unit area. And volumetric charge density, denoted by rho, which is charge per unit volume. That's all about that topic. We will have some important numericals based on the topics which we have learned till now in further videos. Thank you for being here. Stay tuned, and don't forget to like, share, and subscribe, Physics at Fire.